This video is on the skeletal system, part 2. So in part 1, we learned about the roles of the skeletal system and the structure, both microscopic and gross. In this section, we're going to talk about how bone develops and how it repairs. So the first word I'm going to give you means the formation of bone tissue, and it's called osteogenesis. If you look at the word, you'll notice genesis is part of it, and so is osteo. Osteo refers to bone. Genesis, if you think about the Bible, the first book in the Bible is Genesis. It means the beginning. So this word literally means the beginning of bone. When you see the word osteogenesis, it means the development of bone in the fetus, because that's where it begins. Remember that the fetus at about 8 weeks has an entire skeleton. It's just that it's made out of hyaline cartilage. There's another word that is often used interchangeably, even though it doesn't mean the same thing, and that is ossification. So people use the word ossification to mean bone formation, but it really means, it does mean bone formation, but after bone is already in existence. So ossification is when you are adding on bone mass to existing bone structure. Okay, so the words are a little different. They both mean bone development, but again, in osteogenesis, we're talking about development from the beginning in the fetus of bone. Ossification, we mean adding on to bone that already exists. So just a minor difference here. Now, again, bone formation, osteogenesis, begins in the 2nd month of development. So the fetus is about 8 weeks old. It's already got a complete skeleton, but it's, for the most part, it's made of hyaline cartilage. And this bone formation continues in the fetus and goes on into early adulthood. After adulthood, when our bones have stopped growing, they continue to remodel and repair through our entire life, especially if we get a break or a fracture. There are 2 types of ossification. The first one is called intramembranous ossification. And here's a good prefix to know. Intra means within, whereas inter means between. Intramembranous ossification is when bone develops from within fibrous connective tissue. And this is how flat bones form, such as the clavicle and the cranial bones. In your textbook, there's a good summary of intramembranous ossification, and you should take a look at it. The other type of ossification is called endochondral ossification. Now here, chondra, remember when you see that, it means cartilage. And endo also means within. So endochondral ossification is when bone forms by replacing hyaline cartilage. So remember that the fetal skeleton is made of hyaline cartilage. In endochondral ossification, that hyaline cartilage is slowly replaced with osseous tissue or bone. This is how most of the bones in your skeleton form. So we are going to look at this a lot more closely. In addition, if you understand endochondral ossification, you understand how bone repairs. So there are a couple of steps, and in this picture you'll see we're going to look at a long bone. Now, anything that's in blue is supposed to represent hyaline cartilage. Anything in tan here is supposed to represent osseous tissue and bone. So let's look at the first step here. And the first step has a title. It's called Formation of the Bony Collar. This begins sometime around week 9 of fetal development. And what happens here is that you've got a lot of mesenchyme. Now remember, mesenchyme is the embryonic tissue through which all connective tissue develops. So somewhere along week 9, the mesenchyme differentiates. That means it starts to turn into osteoblasts. Okay, so instead of turning into another type of cell like a chondroblast that would form cartilage, or a fibroblast that might form other types of connective tissue, it turns into osteoblasts. And these osteoblasts are going to secrete matrix on the outside of the cartilage, right here. Okay, so they're going to secrete the matrix outside of themselves. On the outside of the cartilage. Okay, so they're going to do it here. You can see it there, and they're going to do it right there. Now the matrix hardens, and you end up with what they call a bony collar. It's kind of like a collar around someone's neck. Okay, so this is the first thing that happens. And the way I remember this is, well, the first thing is called formation of the bony collar. And that triggers me to think, oh, okay, that's the osteoblast laying down the matrix on the outside here of what would be the diaphysis, and then when it hardens, you get this thing that looks like a collar. Now the second step is called cavitation. And in cavitation, a cavity forms in the middle. Okay, so that's a trigger. That's how I remember it. Cavity forms. Now you know eventually there is going to be a cavity here called the medullary cavity. So what happens in this step is that the chondrocytes, remember this is hyaline cartilage in blue, the chondrocytes in the middle here start to enlarge. This is a process called hypertrophy. So hypertrophy is when a cell enlarges, and it's usually a bad sign. It usually means the cell is sick and dying. Okay, so again, the chondrocytes in the middle of here, they start to enlarge, and then they die. And they die via a process called apoptosis. Now, apoptosis means programmed cell death. In other words, all cells have embedded in their DNA their death date, the day they're going to shut down. And so first these cells enlarge, hypertrophy, and then they shut themselves down and die. Once this happens, it's a signal for calcium to move from the matrix outside the bone and into the cartilage. And so the calcium moves in, and that essentially kills the cartilage, because the cartilage needs oxygen and nutrients, and that can't get into the matrix when calcium's in the way. And eventually all of the cartilage dies in the middle, and it caves in, and you get a cavity. Okay, the next step is called invasion of the periosteal bud. This sounds very dramatic. But the periosteal bud is actually not just this. So this looks like, you might think, oh, this is the periosteal bud, but it's not. This is just one blood vessel that happens to be in it. So the periosteal blood includes arteries, like the one you see in this picture, veins, nerves, osteoblasts, and osteoclasts. These all make up part of the periosteal bud. And so remember, you've got a cavity now in the middle, and this bud invades, and it brings with it osteoclasts, osteoblasts. So the osteoclasts are going to come in and chomp on this dead matrix. I always think of osteoclasts as kind of looking like this, you know, like kind of like a Pac-Man. So they come in and they break down the dead cartilage matrix, but they leave behind slivers of cartilage. Then osteoblasts, which come in with the bud too, they come and lay down matrix on these slivers. And what you end up with is spongy bone. Okay, so again, this process is called invasion of the periosteal bud. We start out with a cavity here. That was the last step, cavitation. But then comes in this bud. And I think of this as D-Day. So if any of you know what D-Day is, D-Day was the day during World War II when the Allied troops landed on the heavily fortified banks of the Normandy in France. Remember, we were fighting the Nazis then. And what they did is they arrived in these amphibious vehicles. They look like tanks, but they were boats too. So when these tanks landed from the ocean onto the land, they opened up and out came the soldiers, their guns, and the supplies. That's kind of like the periosteal bud. When it comes and invades the bone, out comes the arteries and the veins that bring in the oxygen and nutrients, the supplies, but also the soldiers, the osteoblasts and the osteoclasts. Okay, so that's this step. Now the next step is called formation of the medullary cavity. And again, these are all happening around week 9 in fetal development. Now you'll see that what we're going to is called formation of the medullary cavity, so that's what's going to happen here. What happens is that the osteoclasts are going to come in and start to hollow out the center here. So if you think of the osteoclasts as these little Pac-Man, and I'm going to show you a real one, so you'll see they actually don't look like this, but in they come and they're going to essentially remove the spongy bone, okay? And this cavity begins to form and lengthen. But then some other things are going to happen. So as they remove the spongy bone, what's happening right here is that is kind of the same chain of events that happened before. So here's the cartilage, here is the cartilage, okay? And the chondrocytes are going to enlarge, they are going to die, and then the osteoclasts are going to come in, chomp on them, leave pieces behind. The osteoblasts come and lay down matrix, and you end up with spongy bone. And that happens at both ends. So what's happening again is that here and here, the cartilage is being replaced with spongy bone. That's what's happening. You'll also notice there's a secondary ossification center in the epiphysis. And what's happening here is the same thing that happened in the middle, is that you have cavitation, step 2, step 3, invasion of the periosteal bud, and then you have this tissue is going to start to be converted to spongy bone. The only difference is you're not going to form a cavity on the ends, okay? So this process here where you get the secondary ossification center, that doesn't happen in all bones in the fetus. Sometimes when the baby is born, the epiphysis is all cartilage, okay? So sometimes this process, this secondary ossification center, doesn't happen until after the child is born, so just an FYI. Okay, let's go on to the next step. Okay, this is called ossification of the epiphysis, and it's got to do with the epiphysis, so this must mean the epiphysis is turning to bone. Now remember, it used to have a lot more cartilage, but now it's only got this thin wedge here, and that is the articular cartilage, also on the bottom. And then it has a thin wedge of cartilage here called the epiphyseal plate, and also here. So what's going on now is that this process of ossification has advanced enough so that now you've only got this much cartilage left, here and here. And this usually happens once the child is born. So this happens from childhood to adolescence. So a couple of things here is that on this side of the wedge. So look at the side of the wedge that's facing the medullary cavity. So this here and here, see that? The bottom of the wedge that faces cavity, what's happening there is the cartilage is replaced with bone. Okay, so what's happening is the osteoclasts and osteoblasts are replacing the cartilage on the bottom with bone. And the same thing is happening here on the part of the cartilage wedge that's facing the medullary cavity, okay? Cartilage replaced with bone. Now, on the other hand, what's happening on the top, so I'm going to draw it from over here, top of the wedge, which would be here and here, is the cartilage is replacing itself. Okay, so on the top of the wedge, cartilage is reproducing, and that's true for the bottom too, here on this part of the wedge and here on the outward facing part of the wedge. So the cartilage replaces itself. So if you think of this kind of as a battle, where the bottom of the wedge facing the medullary cavity, that's the battlefield, and the cartilage is falling, the cartilage soldiers are dying, they're being replaced with bone here. But on the other side of the wedge, the cartilage is bringing in new troops, and it's replacing itself as fast as it can. If you think about it that way, and if I said to you that as a child grows, the cartilage replaces itself as fast as it is replaced. So on this side of the wedge, the cartilage replaces itself as fast as it is destroyed on this side. If I said that, what then would happen to the width of this wedge and of this wedge? As a child grows, does the width stay the same? Does it get smaller, or does it get bigger? So again, here's another way I could say it. If the cartilage is replaced by bone as fast as the cartilage replaces itself on the other side, what happens to the width? Now, if you said it stays the same, you would be correct, because they're balanced. As fast as the osteoclasts and osteoblasts are turning cartilage to bone on this side, on the other side, the chondroblasts are replacing it. So the wedge stays the same width as a child grows. The bone is just going to get longer, and so does the medullary cavity. So I'm going to jump ahead just for a minute to show you real photomicrographs of what's happening at the end of the bone. And there is a handout in the Chapter 6 module for you to go over, and I really recommend it. So it's a good way to study this process, because this can be a little confusing. So let's take a look here. We're going to take a chunk right here at the top of the epiphyseal plate, and this is in an actively growing bone, and here we're looking at it under the microscope. So if we start down here, we are at the bottom of the wedge, and we know that down here we have osteoclasts and we have osteoblasts. And the osteoclasts are breaking down the cartilage, but they are replacing it, they're breaking down the cartilage but leaving pieces behind. They call them spicules, like little slivers of bone. The osteoblasts then come and lay down matrix on top of those slivers. And so you can see right here, what you're forming is spongy bone. Sorry about that. If I color it in, there's a piece of spongy bone. Here's some more right here. It's kind of shaded. It has a matrix. Here's another sliver. Okay, so you're starting to form slivers of bone with spaces in between, which is spongy bone. So this part right here, this zone, they call this the ossification zone, because this is where cartilage is being turned to bone. Now, if we move a little further away from this, away from the battlefront, where the chondrocytes are dying, we come to this area, 3. And there's not much to see in here that helps you know what area this is, but this is where the calcium is coming in, entering the tissue. It's called the calcification zone. And remember, that kind of definitely kills the cartilage. If we move back a little further from the battlefront too, you'll notice here that these are the lacuna here. And the chondrocytes are inside. And you'll notice they're large. These are large lacuna because the chondrocytes are hypertrophying. So they call this the hypertrophic zone. Okay, so remember what's happening here is because the chondrocytes are sick and they're dying, they enlarge. Now if we move a little further away from the battle line down here, you'll notice that all the chondrocytes are kind of on top of each other like pancakes, are stacked up. And that's because they are dividing as fast as they can. They are replacing the cartilage that was destroyed down here. So they call this the proliferation zone, because proliferate means to make more of. Now up here, the arrow points upward, but we can't really see it on the slide. This is the furthest from the battle line. And here, the chondrocytes are just hanging out. They don't even know there's a battle going on. They call this the resting zone. Okay, so let's take another look at another slide here. And again, this is from the epiphyseal plate, the wedge of cartilage. And if we start down here, you can see there is dead and dying cartilage. These smears of pink are actually where the osteoblasts laid down matrix on top of the pieces of dead cartilage. So they call this the zone of ossification. See that? That's pretty much in here. If we move a little away from that, we come to the zone of calcification. This is where calcium is entering the matrix, which pretty much kills the cartilage. If we move a little further away, zone of hypertrophy, and now you can see the chondrocytes are enlarged, certainly compared to up here, and that means they're getting sick. If you move further away, you can see the chondrocytes are all stacked like pancakes here. That means they're dividing, so zone of proliferation. And then if we move really far away to the edge, you'll see this looks like typical hyaline cartilage. And here that the cartilage is resting, so they call it the resting zone. Another slide, again, this is just a close-up. You can see here the hypertrophic zone, and you can really see how these are enlarged. That's a big clue. The proliferation zone, again, we are within a lacuna, but you can see many, many, many different chondrocytes reproducing as fast as they can. And then the resting zone, again, is the cartilage is just resting. It looks like typical hyaline cartilage. Again, another slide. This is a nice picture of the proliferation zone and the dividing chondroblasts. To me, they look like pancakes all stacked up. And the resting zone where the cartilage is not really doing much of anything. I just wanted to show you this. It takes a lot of practice to identify the types of bone cells, and I'm not going to request that of you, but this is an osteoblast right here. So you can kind of see it's kind of flat, looks kind of squamous. Here is an osteocyte, and they look kind of similar. So it's a little tricky sometimes to identify these, but down here is the osteoclast, and this is definitely different than the others. It's a huge cell, has multiple nuclei. Here's one more picture of an osteoclast, so I will try to outline it for you. So I'm going to outline with my pen this osteoclast. It's kind of like this. So it kind of is like a little Pac-Man, and it is basically surrounding and crunching on cartilage, dead cartilage. So these are very large cells. Okay, so I'm going to go back now. I just wanted to go through that. And again, what I really recommend you do is that there is a handout in the module for Chapter 6, and it has all of the bones of endochondral ossification on a sheet, and I've mixed them up so they're not in the right order. And I ask you to put them in the right order and tell me the name of that step. And I think that might really help you learn this. On the other side of that handout is a picture of the slides that we just saw, and I ask you to label the different zones. Okay, so let's say now we have a child who's 6 years old, and their bone looks kind of like this picture on the left here, right? So you've got the articular cartilage, and you've got the epiphyseal plate. And remember, we said that the cartilage is reproducing, it's growing on the top of the wedge. So here and here, cartilage grows on the top. And then we said on the bottom of the wedge, cartilage is replaced by bone. So that's here and here. Well, when bone grows from the inside, like it does in this situation, the inside of the bone, they call it interstitial growth. Okay, so again, when bone grows here on the bottom of the wedge and here, it's replacing the cartilage, it is called interstitial growth. Okay, so here's the child at age 6, but then here's the child's bone at age 9, and you'll notice it's gotten a little bit longer. In fact, here's the outline in red of the child's bone when it was 6 years old. So you can see it's bigger at age 9. So how does that happen? Well, first of all, if you're going to make the bone taller, you have to make it wider to support that extra weight of the body, extra muscle mass. So if you're going to make it wider, you're going to have to add bone to the outside. Not from the inside, but to the outside. And when you add bone to the outside, they call it appositional growth, not interstitial. But in addition to that, you want this kind of smooth shape where it's like a bulb at the end and then thinner in the middle. You want that. So that means you're going to have to shave away this part. So right, this is where the old bone was, right here. You're going to have to shave that away. So can you think of what types of cells are going to remove this? Now, if you guessed osteoclasts, you are correct. So they're going to come in and remove it, and that's what's called remodeling. It's just like when you make something out of clay. You might kind of shave away some parts of it to give it the shape you want. In addition, the medullary cavity here was this thick, right? But now we're widening the bone, so we have to widen the cavity. So now we need to shave off this amount right here just to widen the cavity. So what cells would do that? Well, if you guessed osteoclasts, you're correct. Let's review what we just said. So I'm going to jump ahead here because we've covered these. So once the child is born, the bone's going to grow and remodel. When the bone grows from the inside, it's called interstitial growth. And this is how bones lengthen. Okay? Who does interstitial growth happen in? Does it happen in children or children and adults? So remember, this is how bones lengthen. Well, it only happens in children because once people reach adulthood, they stop growing lengthwise. Appositional growth is when you have growth from the outside. And that's what we saw as the child went from age 6 to 9. You have to add bone to the outside to make it wider. So this is how bones thicken. So as bones grow, they have to lengthen, but they also have to thicken to support the extra mass. This happens in both adults and children. Now, if you're an adult and you've reached your maximum height, as you go through life, if you put on muscle mass, let's say you go to the gym and you build up muscle mass because you want to be a weightlifter, that's extra weight, and that means your bones have to widen to accommodate that. Likely, another example is if you put on a lot of weight, if you put on 50 or 60 pounds, your bones are going to widen in order to accommodate that. Okay, so this is bone growth and remodeling. So what happens at the end of the teen years after puberty is the chondroblasts on the epiphyseal plate, they start to slow down. So remember, this is kind of a race. Show you, this is the end of the bone. Here's the epiphyseal plate. It's a race. So on this side, bone is forming. The osteoclasts and osteoblasts are replacing cartilage with bone. Here, the cartilage forms. And as the bone grows, this wedge stays the same width because the cartilage being produced is balanced with the cartilage being destroyed. But when you get into your teen years, the chondroblasts start to slow down. They don't divide, and this plate gets thinner and thinner and thinner until eventually the osteoblasts and osteoclasts take over and they remove all the cartilage. Then what you're left with in this situation is a line. This is called the epiphyseal line. All right, this up here is called the epiphyseal plate because it's cartilage. And as you know, they color cartilage blue. Okay, so those are important terms to know. A lot of people call this the growth plate. That's a common term. So you might see that, the growth plate or the growth line, but that's not the correct term. So when does this happen in most people? Well, for females, their bones usually start growing a lot earlier than males, maybe around the age of anywhere from 14 to 18. For males, they start growing anywhere from 18 to 21, 22, or 23.